Hello everyone and welcome to the RAF Museum's Trenchard lectures, which are run in association with the Royal Aeronautical Society. I'm Dr Harry Powell, I'm the museum's historian, and it's my pleasure tonight to introduce Dr Matthew Powell. Before I do that, I want to say hello to all of you joining us from around the world. We've got people tonight joining us from Burlington, Budapest, and even Battersea. So wherever you're joining us from, welcome. And during the course of a lecture, if you'd like to ask Matthew any questions for the end of the session, you can do so using the Ask a Question function at the bottom. But I'm really pleased that we've got Matthew with us tonight. I don't just say that because I have his books sitting here next to me. He's a fantastic researcher. He's currently teaching at the University of Portsmouth at Cranwell for the RAF. I'm going to leave him to introduce himself in more detail, but I'm really looking forward to the lecture, which is Forging the Future, the Air Ministry and the Advent of the All-Metal Aircraft. So I'm going to bring in Matthew. Hello, Matthew. You're now live. Take it away.
Hi, Harry. Hello, everybody. First of all, I'd just like to say thank you to Harry, to the RAF Museum and to the Royal Aeronautical Society for giving me the opportunity to present some of my research on the aircraft industry and its relationship with the Air Ministry in the interwar period. To give yourself a little bit of background about myself, I did my PhD at Birmingham in 2014. And then in 2017, I became a teaching fellow at the Royal Air Force College, where I currently still teach RAF officer cadets. And so looking at tonight's presentation, the Royal Air Force faced many challenges in working with the wholly private aircraft industry during the interwar period. The inevitable contraction in defence spending following the end of the First World War, combined with the excess stock that had been ordered prior to the armistice, meant that aircraft firms would not be receiving orders for large amounts of new aircraft in the near future. The geostrategic situation confronting Britain in Europe also led to a reduction in defence spending overall, as there was no realistic enemy on the horizon in the short to medium term. Many of the firms that joined the aircraft industry during the boom years of the war had dropped out, went bankrupt, or were bought by the more traditional aircraft firms that had existed prior to 1914, such as Fairey, Shaw's and Blackburn. When new orders were placed by the Air Ministry, they were small in number and sporadic in nature. This meant that the industry was reliant on producing aircraft largely by hand, as the quantities did not justify the investment in mass production techniques. The move from wooden biplanes to all-metal monoplanes was one of the toughest transitions that the Air Ministry faced, and this was on top of attempting to protect its status as an independent force and attempting to develop a working doctrine from the experience of the application of air power in the First World War. Now, the Air Ministry have been represented in the historiography on the development of aircraft in this period as being overly conservative and resistant to the dawning of this new era. It is argued that the RAF as a whole was resistant to embrace this radical change in aircraft design and were late to adopt it as a method of manufacture, preferring instead to order biplanes as these suited their needs in terms of operations throughout the empire. The argument continues that these developments were the results of competition in civil and not military aviation. The fact that the Air Ministry continued to order wooden biplanes into the 1930s has been offered as evidence to support this view, and there's been little challenge to this line of argument. This lecture will contest this accepted narrative and seek to explain why the RAF was still equipped with a majority of wooden aircraft well into the 1930s, something that is currently missing from the historical literature. Now, in my opinion, this is largely due to the ever-changing technological environment of the interwar period and the difficulty of anticipating changes in aircraft design and construction that may be required. The industry as a whole also had to be convinced of the need for change, which would cost time and money to implement at a time when orders were limited and monies invested would not see a return. Now, the historian Keith Hayward has attempted to provide an explanation, but this argument does not consider the lead times, which are the times between an order being placed and the first production batch being delivered, that the Air Ministry had to work to when procuring aircraft, and so it's rather limited in its usefulness in gaining a fuller understanding. Hayward's explanation is that firms were reluctant to make the change in the materials they were using from wood to metal, as metal was more expensive, despite the Air Ministry believing that the cost of aircraft would be reduced with the introduction of metal as the primary material, combined with greater difficulty in manufacture that metalwork presented. The firms that constituted the industry believe that this base change in their working practices would require a highly skilled workforce and the necessary number of orders to keep this in situ. Whilst this appears to be a convincing explanation, particularly as access to skilled labour was a major constraint to the aircraft industry's expansion in the late 1930s, it only considers the issue from the point of view of the industry and not the constraints and context within which the Air Ministry was working. Now, another historian, Colin Sinnott, has rightly identified that the Air Ministry made it policy to only procure all-metal aircraft as early as 1925, but still claims that this was something of a misnomer because wooden secondary structures and fabric covering continued for many years. Now, this decision made in 1925 was confirmed in 1926, and so this we can see as being the true date from which the RAF decided to move from wood to all-metal aircraft. There is also evidence to suggest that other nations continued to develop wood, string and canvas biplanes long after the RAF moved to all-metal production. It demonstrates that the Air Ministry was aware of the importance of moving to all-metal aircraft construction as early as 1926, but they were unable to do so for a variety of factors. Some of these factors were well within the capacity of the Air Ministry to change. However, there were several important factors that were not. Now, production orders went to the firm or firms who had designed and built prototype aircraft that met or exceeded Air Ministry specifications. Those that failed in this endeavour received nothing in the way of monetary compensation for the months or years spent designing and building aircraft. This, combined with the problem of dealing with an aircraft industry that appeared to be on the verge of almost continual collapse, meant the Air Ministry also had to consider the vast leaps in aviation technology that even in the mid-1920s was threatening to make the latest aircraft to come off the production line obsolete within a matter of months. In 1918, the Air Ministry found itself in a position where it had no requirement to order new aircraft for several years due to production rates in British firms. Firms were advised that with the end of the First World War, the newly formed Air Ministry would accept aircraft that were currently in production, but that new aircraft were not to be laid down. Now, this situation lasted within the aircraft industry in Britain until 1922. Now, the interwar period saw some of the most radical changes in the history of aircraft development that were only arguably bypassed by the development of the jet engine. The design of aircraft moved from a bi- or triplane structure to that of a monoplane. In addition to this, retractable landing gears aided the aerodynamic shape of aircraft, which, when added to the developments in engine power and output, placed greater stress on airframes due to the greater speed aircraft could travel and the tighter turns that could be made whilst in the air. Variable pitch propellers allowed the nose of the aircraft to be adjusted for takeoff and level flight. This meant that engines could run at an efficient rate during both aspects of flight to prevent stalling at different speeds, allowing them to work at their most economical rotational speed, thereby prolonging the life of the engine. This was a vital consideration as the development and building of aero engines was fraught with difficulties and had posed a problem for the Air Ministry before 1914. Britain had no real aero engine industry to speak of when war broke out in 1914, and the majority of their aero engines were manufactured in France. Now, a burgeoning but fledgling industry developed, but this was limited in both scope and nature and was largely diminished after 1918. Only a few firms remained in the business of manufacturing aero engines in the interwar period, something that would pose a challenge as the European political situation deteriorated in the 1930s. When rearmament started in 1936, one of the biggest problems faced was not the number of airframes being produced, but the number of aero engines available to fit within the airframes. While some of these innovations, such as variable pitch propellers, predate the advent of all-metal aircraft, it was this change in aircraft material that allowed the incorporation of the other technological developments to create the next generation of both military and civil aircraft. All-metal aircraft could handle the additional stress of flying at the speeds that new engines could generate, as well as the additional G-force from the tighter turning circles, as the heat treatment of the steel meant that it was a stronger material for the weight of metal used. With the creation of all-metal aircraft, the days of wood, string and canvas biplanes were gone, replaced by the monoplane with stressed skin that could now provide the pilot with relative comfort in an enclosed cockpit compared to the open cockpit of the biplane era. Pilots in an enclosed cockpit would be more protected from the elements, but they would also be able to fly higher, as they would not have the problem of the relative lack of oxygen at altitude, as this could be provided within the cockpit, enhancing the capabilities of the new types of aircraft being designed. The time taken to develop an aircraft, even in the mid-1920s, was around 5 to 9 years, and the average life of an aircraft in frontline service was approximately 5 years before a replacement was required. An example of this is given in a letter written by the Air Member for Supply and Research, Air Vice Marshal Geoffrey Salmond. Quote, "Let us assume that a design of a single-seat fighter, which we will call X, is issued as first-line equipment to all single-seater fighters in squadrons in 1927, having previously been tried out and developed under the system that was being used. The Department for Technical Development would then forthwith start the development of Design Y, intended to replace X in 1932. Now, this meant that the Air Ministry had to be considering what their requirements were for the next model of aircraft for any given type, almost as soon as the previous model that had been undergoing development had entered frontline service. Almost by default, the Air Ministry had to be naturally conservative in their approach when laying out a specification on how far they were willing to incorporate new technologies, as there was a serious risk that new technologies may not turn out to be as useful or as groundbreaking as the inventor had claimed. The Air Ministry had a duty to spend the public money it was granted with care and could not afford to invest heavily in every developing technology, and this degree of caution was freely admitted by the Air Council. It must also be considered that the pace of technological change in the construction of aircraft, combined with the slowness of development from the issuing of a specification to the first batch of production aircraft rolling off the production line, resulted in a long and laborious process that inevitably encountered delays. With the Air Ministry having to issue a specification for a new type of aircraft almost as soon as the first production run of the previous model was ending, the decision to change the whole basis of manufacture to all metal types was a risky one that would have led to widespread criticism if it had failed. If the RAF had inferior aircraft, this would have the potential to place them at greater risk, both in military and diplomatic terms, as they could easily be intimidated and dominated, as the population could be placed in harm's way from the air, limiting the government's freedom of action across the globe. The culmination of this potential weakness could see the government fall, as had almost been the case during the First World War, when public outcry over German aerial attacks caused the coalition government under Prime Minister David Lloyd George to remove air assets from the Western Front to protect London and the southeast of England. The threat to the homeland was also a factor behind the decision to create an independent air RAF in 1917, with it coming into existence on the 1st of April 1918. The Air Ministry was also faced with having to force a massive upheaval and revolution on the firms that supplied it with aircraft. To alter the entire basis of the manufacture process, as well as the materials utilised, would have required heavy investment from individual firms, the complete redesign of their manufacturing processes, the training of staff to work with new materials, and the purchasing of new jigs, tools and machines. With the paucity of orders available to individual firms, combined with Air Ministry efforts to alter the procurement system in an attempt to build a long-term strategic capacity in both the ability of the industry as a whole and the numbers it could produce in a time of national emergency, the firms were reluctant to do this, as there would be no real return on their investment. The Air Ministry were able to provide a limited amount of funds to aid the firms in this process, but could not cover the whole cost. The Air Ministry had a limited budget, and this had to be spent on several different priorities. They had to spend the public money they were allowed wisely, and were further hampered from helping aircraft firms from changing their production methods and training their staff. As private firms, the individual aircraft companies were responsible for their own success and failure as businesses, and the Air Ministry could not simply step in and provide additional resources outside of orders for aircraft. If one company were given additional money, then the Air Ministry would be compelled to provide the same, if not potentially more, to other firms. This would prove to be costly and would also set a precedent that the firms could go to the Air Ministry either as a collective or on an individual basis whenever changes were required to the manufacturing process or equipment required upgrading. The potential results of this emerging transformation are clear to see when such a move was attempted during rearmament of the RAF from 1936. Although the firms were now producing only all-metal aircraft and public money was available to a greater degree to aid firms at this time, the massive expansion between 1936 and 1939 gives some indication as to what would have happened if all-metal aircraft had been forced on the industry in 1926. Similar problems are faced in military procurement today, and the procurement of aircraft is one of the best contemporary and historical examples of the problems that are faced. Procurement departments have to make long-term decisions on undefined and undeveloped technologies that may become the minimum standard throughout the world or simply not come to fruition. Once this decision is made, however, it does not stop the advancement of technological developments, and it's likely that given the time taken to design and develop the latest model of aircraft, the technology within it will be largely outdated and obsolete. But a decision on when the technology is right has to be made at some point, or it never will. Given the difficulties and complexities of building aircraft, it is always highly likely that they will be longer in production than the original supplier's estimate, and the production process will be more difficult, with unexpected problems to be overcome and staff trained in new techniques. That this is a major issue today should come as no surprise, given that it was a perennial problem in the 1920s and 1930s. Firms then, just as today, had a tendency to overpromise and underdeliver, as they underestimated the problems they would face in production and how far they would have to change the layout of their factory to accommodate the latest model. The expansion of production was severely curtailed due to a number of factors, of which the availability of money, either public or private, only played a small part. The bigger issues facing the aircraft industry in its attempts to increase production to meet the almost overwhelming demand of the RAF was access to skilled labour, the availability of jigs, tools and machines, and the floor space required in individual factories required to manufacture the next generation of machines. There was also the issue of having to learn to produce these aircraft using mass production instead of piecework methods. All of the issues that presented themselves in 1936 would have presented themselves at the point that the Air Ministry decided to move to all-metal production. This was hampered even further by an aircraft industry reluctant to embrace the change due to a lack of prevailing orders and a global and strategic outlook, making it difficult for the Air Ministry to emphasise the patriotic nature of the task the industry was being asked to undertake. Considerable resistance from the industry could be expected. And all of this would have taken place while the industry was also learning to use new materials, and production deadlines would have been missed on a regular basis. That this happened on a regular basis regardless is testament to the problems of manufacture, as well as the rapid and unexpected changeover in materials, as well as the new requirements in skilled labour. The move to all-metal aircraft was not initiated by the Air Ministry, but by the private firms who sought to enhance the capability of aircraft in terms of speed and endurance, although the Air Council was very quickly convinced of the advantages that all-metal aircraft brought. The additional speed, ceiling and rate of climb of the new all-metal aircraft would give the RAF a distinct operational advantage over their potential European opponents. The new aircraft would also have an advantage in areas such as their turning circle, enabling them to outmaneuver their opponents in dogfights. The industry was largely motivated in this endeavour by international competitions such as the Schneider Trophy, which placed an emphasis on the speed an aircraft could reach in order to determine a winner. Despite being a race for seaplanes, the Schneider Trophy proved to be an important testing ground for new designs and materials. The first British all-metal aircraft to be entered into the race was in 1927 with the Supermarine S5. For a British aircraft of all-metal construction to be ready to compete in 1927, work must have been taking place in both the design and construction aspects as early as 1925, if not earlier. Now, due to the biannual nature of competitions such as the Schneider Trophy, there was very little incentive for firms to incorporate all-metal manufacturing into the aircraft that were being produced to supply the RAF. A move to such a practice would have caused major disruption to the production of aircraft, and potentially to massive delays in deliveries as factories and workshops were reorganised and production staff retrained. The cost of building such an aircraft would also increase over that of wood, canvas and string, as due to the limited number of aircraft ordered by the Air Ministry, mass production techniques could not be initiated. This meant that all metal production would have to be completed by hand, involving a large number of man hours, with the associated costs of labour added to the initial cost of the aircraft. The Air Ministry were hopeful that a move to all metal aircraft as standard industry practice and the associated move to production techniques more in line with mass production instead of piecework could lead to a reduction in overall aircraft costs. The adoption of metal as the standard material was almost a foregone conclusion once the operational advantages were made clear. The problem for the Air Ministry, however, was not that this should become the minimum standard. It also had to be financially viable for the firms, and the operational necessities for the RAF on active operations in the Empire meant that such a transition would not become a priority until other nations also started to adopt metal as their standard. This was because the Air Ministry, believing that metal would be cheaper than wood and that production processes could be streamlined, thereby reducing the amount of time required to manufacture individual aircraft. In order to achieve this cost saving, the move to all metal aircraft would have to be accompanied by contracts of several years' duration to allow firms to establish their factories in a more economical and efficient manner. This would result in lower overhead costs for the firm as well as lower labour costs. Until the numbers of aircraft ordered by the Air Ministry increased and continued to do so over several years, thereby demonstrating to the industry as a whole that they would see a return on their investment, firms would be reluctant to convert their standard production processes. The Air Ministry were keen to impose a policy of purchasing only all-metal aircraft in 1926 and put forward proposals for how this was to be achieved internally on this basis. This was debated and discussed at length. The result was the authorisation by the Air Member for Supply and Research to adopt this policy in July 1926. The potential adoption of this new policy did not, however, take into account the lengthy lead times involved in the development and production of aircraft. The competition to win the right to produce a new aircraft was a long and drawn-out process that began with the issuing of a specification to private manufacturers on which their designs should be based. Once these designs had been completed, it was down to the individual firms to produce a prototype aircraft at their own cost and risk. These prototype aircraft would all be brought together for a series of tests, which included meeting the minimum specifications laid down in terms of climb rate, ceiling, speed, and bomb load, amongst many other factors. They would also be tested to ensure the overall safety of the aircraft. The expected length of time for this process to be completed was 2 years. And this was a long period of time for the individual manufacturers, particularly those who had not received production orders for an extended period. There would be no payment made to firms whilst this process was undertaken, and so any costs had to be borne by the company in the hope of recouping this outlay through having their own design selected. In order to survive these potentially lean and difficult periods, firms were reliant on finance from one of two major sources. The first was to rely on the savings and profits earned from previous orders to continue to pay salaries and wages and maintain equipment and factories. The other option was to rely on the generosity of creditors in the form of shareholders and, more importantly, banks. Nearly all aircraft firms during this period were heavily overdrawn with their banks and often turned to them as a source of credit. The one or two successful designs would be selected, and the firms who had designed them awarded experimental production contracts to build a small number of additional aircraft that would be sent to squadrons for longer-term testing. Those firms who had failed to produce an aircraft that won the open competition would have to bear all the cost of the design work and prototype construction. This made the competition ruthless, and firms were unwilling to allow successful designs to be subcontracted out for fear of revealing trade secrets or giving competitors an advantage in the next competition. This experimental period lasted for around a year and was a period of intense manufacturing by the selected firms to provide 6 to 12 aircraft that could equip a frontline squadron. If the aircraft successfully demonstrated its capabilities during the experimental period, a further contract would be placed with the firm, which would include the incorporation of any modifications for a development order. Again, this period would last approximately 1 year and allowed the firm to redesign its production processes. Once the development order had been completed, the aircraft would then go through service trials. It was at this point that the pilots of the squadron were able to make suggestions for more improvements in aircraft safety or performance. And these modifications would then have to be incorporated into future production of the machine. Once these modifications had been incorporated into the manufacturing process and new prices quoted, the machine had successfully passed its service trials, it was then accepted as standard equipment for the relevant squadrons. Now, modifications were a bane of aircraft production as they added additional cost and delay to the manufacturing process, requiring changes in procedures in the manufacturing processes. If modifications were major in scale, they may also require the creation of additional jigs and tools to make the necessary components, adding to the manufacture time. These changes that were largely adopted after the initial manufacturing stage of aircraft production meant that construction was delayed and the initial delivery dates redundant as the firm had to learn to adopt these new processes. The Air Ministry hoped that by adapting their procurement process in this way, they would be able to ensure a continuous flow of work through individual firms by spreading the changes over a 5-year period. Now, one of the biggest factors behind the idea to move to a 5-year production schedule was that in order to meet the demand for aircraft, which usually occurred quicker than the 5 years that was expected, the Air Ministry would order aircraft at the experimental stage. This resulted in large-scale modifications having to be incorporated at the production stage. It was also expected that the number of modifications to be incorporated into the design of a new aircraft could be reduced to an absolute minimum. If these modifications could be reduced to those only required for safety reasons, the efficiency of aircraft production would increase exponentially. By highlighting what modifications were required during the development period, the Air Ministry argued that it would be able to negotiate a full production contract with the firm concerned that would embody all modifications required. It was also believed that such a 5-year ordering system would reinvigorate the design element of the industry, as firms would see a real incentive to improve their design capabilities. By having a definite period for the changeover of types, firms would benefit from exploring new ideas and utilising government research establishments to further develop and refine initial design concepts. Now, given the heavy investment required in aerodynamic research from individual firms for their own use, the government allowed access to their facilities at the Royal Aircraft Establishment at Farnborough to conduct experiments in the latest design of airframes and wings to make future aircraft as efficient and reliable as possible and give the best possible operational advantage. An expansion of aircraft design, which the Air Ministry believed would make British manufacturers the best in the world, would have further far-reaching consequences. It would make British aircraft more desirable abroad, thereby increasing British exports and providing an external market for manufacturers. This was a market that could still be exploited when firms were unsuccessful in the latest round of procurement, as they could still approach overseas buyers with aircraft that were still largely innovative and superior to anything available in their home country. Exports were also important in several other ways. Excuse me. A successful design could provide a degree of income for individual aircraft firms, as they could sell the license to manufacture to firms overseas. Excuse me. In addition to this, selling aircraft abroad earned the necessary foreign exchange required by government to allow it to continue to purchase the raw materials required for the wider armaments industry. Whilst not of great concern in the mid to late 1920s, the establishment of an export industry that was world-leading would be of vital importance to wider economic and strategic thinking in the 1930s. This 5-year production plan, however, would force the Air Ministry and the Air Member for Supply and Research especially into having to make very difficult decisions. They would have to be certain of the aircraft chosen from prospective designs, as there would be no option of trying to develop a further aircraft after final confirmation of one or two models that had proven themselves at the prototype or experimental phase. If an aircraft did not meet expectations, it would mean a capability gap that could not be filled until the next round of procurement. The RAF would have to continue with an inferior aircraft that would potentially either leave the defence of Britain's airspace at risk or limit their effectiveness conducting strategic air attacks. These decisions would have to be made by working with the aircraft industry and its trade body, the Society of British Aircraft Constructors. If the Air Ministry tried to force something as radical as all-metal production for its aircraft against the wishes of the industry and the Society of British Aircraft Constructors as a whole, the already fractious relationship that existed would become even more difficult. Eventually, the industry would be forced to accept the fact that the capabilities and future potential of metal as the standard material for aircraft construction made this change inevitable. But this did not mean that the changeover was one that was simple to adopt. The nature of the relationship between the industry and the Air Ministry had a profound effect, particularly on the attitude of the Air Ministry, who was the almost sole customer for the private aircraft industry, should have had the self-confidence to direct the industry as it wished. The Air Ministry, however, was all too aware of their reliance on the aircraft industry to provide them with the new models, and although this was a mutually beneficial relationship, the industry sought to exploit the Air Ministry's fears to gain the upper hand and sometimes dictate how the relationship unfolded. Despite the mutually supporting nature of the relationship between the aircraft industry and the Air Ministry, the Air Ministry were more fearful of aircraft firms either refusing to supply the RAF or individual firms going out of business, more than the firms were concerned about this eventuality. This meant that firms were more willing to try to gain an advantage at the expense of the Air Ministry and to take greater risks in doing so. The Air Ministry were not able to run the risk of having no aircraft industry to supply the RAF with aircraft, and could not, as a great power, procure aircraft from overseas. This made them relatively more cautious in their dealings with the aircraft industry, as they had to ensure a supply base remained in being under all circumstances. Having to make decisions on the next aircraft model as the latest came into general service meant that the Air Ministry had to be cautious in which new developing technologies it embraced for the new model. Whilst no one at the Air Ministry doubted the importance of all-metal construction, the techniques involved had never been utilised to produce more than a handful of aircraft. Now, the Air Ministry, while wanting to embrace any new technology or development that would allow it to gain an operationally decisive advantage, could not run the risk of having massive delays to production by the firms involved in the manufacture of all-metal aircraft. This may cause a capability gap, leaving the RAF and the UK vulnerable. So a careful line had to be trod when making these decisions to avoid this potential situation. Not only did the Air Ministry have to tread a very thin line in terms of retaining the capabilities to defend the British homeland, they also had to ensure industry remained cooperative. As would be experienced by Neville Chamberlain and his government when rearmament started in earnest in 1936, the aircraft industry remained resistant to change unless there was a direct benefit to them. There already existed a deep mistrust between the Air Ministry and the aircraft industry over a number of issues, including the expansion of the use of subcontracting outside of the designing firm, and the expansion of the capacity of the industry in general to meet a national diplomatic crisis or unexpected declaration of war. Both of these proposals, when they were put to the Society of British Aircraft Constructors, were met with fierce resistance and put the Air Ministry in a very difficult position, as without a willing and pliable aircraft industry, development in design and production techniques would simply grind to a halt. So the Air Ministry had to maintain a precarious balance between ensuring they received what they required from the industry in terms of technical and technological developments, without pushing so hard that they alienated manufacturers. The Treasury and Parliament as a whole felt that they were not getting the best value for money from the industry, and the Air Ministry should adopt a more aggressive stance with firms, both individually and as a whole, to reduce the general cost of aircraft by introducing methods such as subcontracting, placing greater pressure on the decision-making processes. Now, if subcontracting were adopted after the move to all-metal construction, there would be an issue with the capacity of certain firms to take on work other than their own designs. If a firm didn't have the capability to work with metal materials, the capacity of the industry would be significantly diminished, and the subcontracting would not bring the expected benefits of a more capable industry in general, and alongside a reduction of prices. There was also a certain degree of criticism over the 5-year ordering cycle from within certain sections of the Air Ministry, although these criticisms were not as strong as those from individual firms and the Society of British Aircraft Constructors. One point of criticism was that it would be possible to replace aircraft every 5 years, and that Air Ministry protocols meant that it was longer than 5 years before decisions were made on new aircraft being developed from the date at which investigations and specifications began. The time required for firms to design, build and trial an aircraft did not fit within this 5-year cycle, and such a policy could end up doing more harm than good to the procurement and development of the latest generation of aircraft, particularly when considered against how quickly aviation technology was developing in this period. It was also believed that despite any plan put into place by the Air Ministry with regards to a move towards complete all-metal construction of future aircraft, this could not be accomplished for several years, again largely due to the sparsity of orders with aircraft firms and few all-metal aircraft being forecasted in the short to medium term for RAF requirements. The number of years in between aircraft being replaced, whether that be 5, 7 or 9, is hardly of consideration within this context. It still presented similar problems to the Air Ministry in terms of when to incorporate new technologies and having to consider the next type to be produced as the current aircraft was entering service. This became an almost impossible circle to square for the Air Ministry, and some credit must go to the staff who managed to achieve what they did with as little real disruption as possible. Despite the protestations of certain parts of the Air Ministry and the industry itself, it was eventually decided to introduce a 5-year ordering cycle for new aircraft in an attempt to invigorate the aircraft industry, and its design potentialities. Introducing a wholly new and original production method without the consultation of the industry through the Society of British Aircraft Constructors would meet fierce resistance, despite the fact that some individual firms, such as Supermarine, had already begun to utilise all-metal production techniques for experimental aircraft. Such a request, if followed through by the Air Ministry, would see firms having to radically alter their entire production setup. Skilled workers, such as master carpenters, would either have to be retrained or made redundant in order to make way for those who are skilled at working with metal. This would cause both the Air Ministry and the government of the day problems in their relations with the trade unions. This new or retrained labour would require lengthy training at the firm's expense before they would be able to work effectively in what would be a completely new environment. The tooling required to manufacture wood, string and canvas biplanes would become redundant, and a heavy investment in new tooling, jigs and machines required. This cost would again be borne by the firm if they were to solely concentrate on all-metal production. As ongoing business concerns, individual firms would only be willing to make such an investment provided the number of aircraft ordered by the Air Ministry was such that it allowed them to see a return on these monies invested. With a reduction in defence spending more generally and the cancellation of the planned expansion of the RAF that had been authorised in 1923, any future increase in the number of aircraft ordered in any given year seemed highly unlikely. This was the conundrum that continued to face both the Air Ministry and the successive governments of the interwar period. The capital was simply not available to the Air Ministry to allow them to increase orders to allow the industry to improve its capabilities. Without the guarantee of additional orders, the industry overall saw no business case for investment in either expansion or transformation unless absolutely necessary. There would have to be a radical change in the prospects for firms considering constructing all-metal aircraft, and this came in 1926 with the RAF's announcement that they would only look to procure all-metal aircraft. Once one firm had stolen a march on the rest, there would be furious efforts to return to the previous position of relative equilibrium. Whilst there are examples available of aircraft firms beginning to turn to using metal in their construction methods, these are rather isolated and a reflection of aircraft pioneers exploring what might be possible rather than designing and building an aircraft that would suit the needs of the RAF. This is very similar to the idea of the concept car within the automotive industry. The concept car is a way of pushing the boundaries of engineering and technology rather than creating a car that is marketable to the masses. Now, these actions by these airframe owners and their staffs was keeping alive the spirit of the pre-1914 era, where aviation pioneers would look to achieve new feats simply because they could, and not necessarily because there was the promise of large-scale investment. Aside from limited production orders from interested amateurs, the only real source of income for aviation companies prior to the First World War were the prizes offered by newspapers for achieving certain feats, such as flying from London to Manchester non-stop. With the transformation of aircraft building from a pioneering hobby to viable business, the attitude of the early aviation pioneers changed dramatically. After seeing the potential profits available as a result of new inventions, methods, or techniques, those who led aircraft firms were still keen to push the boundaries of what was possible. These developments, however, would now come at a price. The pioneering spirit of the early Edwardian era had disappeared and was replaced by the hard-headed business mentality of the 1920s. This change in attitude has come as somewhat of a shock to the air ministry, and the face of the industry required a sea change in how they were approached in future. The air ministry was also hamstrung in its efforts to pursue all-metal aircraft construction by the geopolitical situation that dominated the 1920s and early 1930s. The end of the First World War saw all major European nations in no fit state to contemplate a major war on the continent. Whilst this allowed Britain to revert to its pre-1914 strategic posture, defence of Britain and the Empire, it also meant that there was no real operational urgency to adopt the most technologically advanced aircraft. The control and maintenance of law and order in certain parts of the Empire was achieved through imperial policing by the RAF, who operated in conjunction with the army, but took on the majority of operations themselves. The potential enemy in imperial policing operations were described at the time as, quote, semi-civilized peoples who had no access to aircraft, and given their remote location in areas such as the northwest frontier of India, could not have imagined anything being able to fly. In certain cases of imperial policing operations, the sheer shock value of an aircraft flying overhead had such an impact that without any kinetic action at all, the recalcitrant tribe stopped their rebellion and allowed law and order in the particular village to be restored. The desire to move to the procurement of all-metal aircraft was not achieved in the 1920s due to the factors outlined above. As the mid-1930s approached, however, it became clear that this change could be resisted no longer, and the Air Ministry began to issue specifications for all-metal aircraft and allowed previous models built of wood, canvas and string to run to the end of their service life, thereafter being replaced with the next generation modern aircraft. This move was largely driven by the Air Ministry, who made clear the risks falling behind other major nations and the limited opportunity to catch up if such changes were not implemented. The operational disadvantages that presented themselves were eventually too great for this change not to be implemented. This would have an impact not only on the RAF's ability to defend the British homeland, but also on how the nation was viewed as a whole. If the UK were unable to afford or compel their aircraft industry to adopt the latest generation of aircraft, this would be a massive blow to Britain's prestige and global standing. They would have less influence on global and European affairs and would lose their status as one of the foremost nations of the world. The move towards all-metal construction for aircraft was in its most basic form completed by 1930. Whilst the industry as a whole experienced a relative degree of difficulty in changing from wood to metal in aircraft construction, the changeover was not as difficult or problematic as it could have been. This was largely because the industry already had a degree of experience in working with metal and had to transfer this knowledge and the skills gained and increase the scale of production. This transition was eased by the fact that although Air Ministry policy was not to order wooden aircraft after 1926, the lead times involved in design and production combined with the life of aircraft in service meant that this was a transition that happened gradually rather than overnight. This was a process that had begun as early as 1927 with firms looking to exploit new materials despite the myriad of business issues noted earlier. Firms were willing to be pioneers in this aspect of aircraft construction, just as they'd been pioneers in aircraft construction in Britain in general. If they could be the first to utilise metal in production aircraft, they would steal the technical march on their rivals and be able to provide the RAF with the most advanced aircraft available. They would be able to justify their investment in both plant and labour through the additional orders they would receive. This then set the standard for aircraft construction, and in a remarkably short space of time, the whole industry was faced with the prospect of constructing aircraft in metal or going out of business through a lack of orders and the ability to demonstrate a competence in utilising metal in prototypes for future specifications. Now, it must be noted that despite all of this, as early as 1928, all major British aircraft firms were involved to some degree or another in the metal construction of aircraft, but this varied between firms and wasn't put into the wider piece production that was used for RAF aircraft. That the change from wooden to all-metal aircraft occurred at such a rapid pace meant that orders and contracts were still valid for aircraft designed prior to the changeover. These were contracts that had to be honoured by the Air Ministry, and these were usually over a 5-year period, and specifications may have been issued previously that did not take into account all metal aircraft. Firms were also still developing their knowledge and expertise in working in the new material, and so were not as efficient in producing the required number of aircraft. This forced the Air Ministry into a difficult decision: accept technologically inferior but numerically superior aircraft, or technologically superior aircraft in fewer numbers. This, for me, explains why the Air Ministry was still ordering and receiving aircraft into the mid-1930s. The aircraft industry was simply not set up in such a way that they could move completely away from wooden construction, whether that was in a wooden aircraft or a composite wood and metal machine. By 1930, every firm, with the exception of de Havilland, who did not have any government contracts, were working in metal. But for this to be seen in the final aircraft coming off the production line would require the lead time of trials and modifications to be got through. The transition had begun by replacing wooden parts with metal components where they could be made into a similar shape and size. This was achieved through handwork and not by machines that were able to produce them on a mass production scale. The acceptance of all metal aircraft construction by the aircraft industry did not, however, have the revolutionising effects the Air Ministry had anticipated. There had been no standardisation of production across the industry, and the move to mass production techniques had still not occurred. The orders were still far too small for any particular type to justify the investment in new equipment, and it was also quickly realised that there may never be a standard method of construction of all metal aircraft. Estimates on if this were ever to occur were that it would take around a decade to achieve. When utilising metal, firms were using different production methods that used the materials in different ways, and three potential options presented themselves when using metal over wood. They could use sheet metal, which could be cut and bent into the desired shapes to construct the various parts of the aircraft. Tube metal, where appropriately sized metal tubes would be welded to a metal frame, allowing weight and stress to be distributed more evenly across the structure. And strip metal, which was similar to sheet metal, but differed in size. The latter was much smaller than sheet metal and therefore more versatile in its application and could be ordered according to the size required. The construction process for strip metal reflected that of sheet metal. So to conclude, the Air Ministry faced many difficult challenges in their attempts to advance technological developments in aircraft design and construction in the interwar period, and no bigger challenge was faced than the introduction of all-metal aircraft. Certain structural issues, such as the procurement cycle, meant that the Air Ministry were forced to take a more conservative approach to the adoption and incorporation of new technologies. Any failure of new technology would leave the British nation exposed and her defences weakened. Failure could also lead to increased cost and delays as manufacturers learned how to work with new materials, and there will be a long and potentially non-linear learning curve where progress was haphazard and only certain firms able to deliver. The industry also had to be convinced of the merits of investing their own money, gained from either profits or credit, to be able to construct all-metal designs. With the sparsity of orders in the short to medium term, there was little hope of the Air Ministry being able to convince the aircraft industry of the benefits of all-metal construction for national defence and security. Due to restrictions in the defence budget, the Air Ministry were unable to subsidise the firms to ease the transition from wood, canvas and string to all-metal, nor could they force an increase in orders to allow firms to make a return on their investments. Eventually, the pressure became too much for the industry to bear, and the move to the all-metal construction of aircraft was achieved as individual firms vied to show their continued relevance to the only real customer they had, which was the Air Ministry. Whilst there were isolated pockets of work being conducted on metal construction, it was the driving nature of individual firms in competition with each other, plus the Air Ministry's identification of this new material, bringing together several other innovations in aircraft that transformed the face of aircraft construction in Britain. Thank you.
Okay, thank you very much, Matthew. That was great. I'm going to give you a chance to catch your breath for a second. I'm going to
Thank you.
Pull the camera onto me where it obviously should be. And I think it's a good opportunity to say to our audience that whilst this is the last in our Trenchard lectures for 2020, we will be having them again in 2021, starting on Crowdcast. And we hope at some point to return to the Royal Aeronautical Society at Hamilton Place. Of course, that's very much dependent on circumstances. But a really good opportunity to thank the Society for the support they give us, both this year when we started in February with Andy Curtis talking about strategic direction. Hopefully some of you might have been at that. But if not, then I should say to all of you, they've been very generous in providing their facilities and some catering when we host these lectures in person. It's great that we can return that by really promoting the work that they do. They're a fantastic organisation. But we also have lectures continuing in 2020 in December, when Tom Hopkins, who's a curator at the RAF Museum, will present on Cold Waters, RAF Coastal Command and the early stages of the Cold War. And in 2021, we already have lectures lined up for the 11th of March, when Mario Gilli will be discussing jet technology in China as part of our series with Lancaster University. And on the 4th of March, the first of the Royal Aeronautical Society's lectures with the museum will involve Kathleen Sherritt, presenting on female air crews in the 1990s, both personal experiences and policy. I think it's a really exciting lecture, and Kathleen's a fantastic researcher. But without any further ado, we're going to bring Matthew back in because we've got some fantastic questions for you, Matthew. And I thought your lecture was brilliant at presenting the sort of interrelated pressures of the interwar period development, which the RAF had to navigate through. And one of those, I want to ask how successful you feel it was, particularly in comparison to foreign competitors, what was happening in America, France, Germany.
In terms of sort of the move through the materials in aircraft production.
Yeah.
It's a similar story, I think, throughout Europe and particularly America. America is an interesting one because they adopt a different approach to their aircraft industry. They essentially, similar to what France does, essentially try and nationalize it and sort of just farm orders out to people. But the sort of development of metal and the operational advantages it's giving you is being noticed by the French, the Germans, despite not legally having an aircraft. As looking at this, the Italians, the Americans. So it's very much a trend that's happening throughout the time that people are seeing the advantages that you can gain by having all metal and the changes you can incorporate into all metal with retractable undercarriages, variable pitch propellers, etc. And so what you see is that they're all sort of coming to this around the same time and struggling in a way to try and adapt their industrial processes, and they do that in different ways. So as I said, the French go down a more nationalized approach and try and foist this on the firms, but they encounter similar problems, and so everyone's dealing, I think, with the same problems in sort of trying to transform the production process.
Yeah, I've got a really good question here from Alan Brocklebank, I think it is, and he says, could you say a little more about the role of the Royal Aeronautical Establishment and the Society for British Aircraft Corporations in developing standards for materials and standard aircraft general standard parts before the war?
I wish I could. It's not something I've looked at a huge amount in terms of that. What I do know of the sort of Royal Aircraft Establishment is that they have things like wind tunnel set up that these firms don't have access to because they can't invest in them. And so they can loan these wind tunnels to trial new wings, new shapes for cockpits, for the length of the aircraft as well. But it's not something I've looked a huge amount on in sort of the standardization of parts from the British Aircraft, from the Society of British Aircraft Instructors. So it's certainly something that will probably come up during the course of the research, because I'm still in the middle of researching this for a book to be published in a few years' time. But right now I don't have that information, unfortunately.
I think that's a really great question there. I really enjoy finding out about that. So we've got a question here, which is sort of covered by two questions, which there's Hawker's aircrafts and they go into the war with Hurricane. Can they really be considered true metal constructions as they relied on fabric and wood? And was this simply a halfway house between the arrival of true all-metal aircraft?
It's classed as an all-metal aircraft because the major components are made out of aircraft. Despite parts of the Hurricane being made out of wood, it's still classed as that all-metal aircraft because the majority of it is made out of metal. But what we see throughout the sort of the 20s and the 30s is we don't just move straight from wood to metal. We do have composite construction where you have half wood, half metal aircraft, which makes it sort of an interesting transition where firms are starting to learn to use metal, how they might go about doing it, the problems that they're going to have, the skills that they need, the sort of components, the production processes, jigs, tools, things like that, machine shops, what they'll need in terms of floor space. So we do see a sort of transition, but the Hurricane is very much classed by the Air Ministry as an all-metal aircraft.
I'm having to restrict myself because I could get really enthusiastic in going into this area, but we've got so many questions, I'm going to restrain myself. We've got a great question here, which is, were there any particularly notable problems due to the poorly understood science of metal fatigue? Of course, still perfectly understood right in for the post-war period, and the well-known demise of a comet is referenced here, but the general challenges of working with metal in this area. In
terms of metal fatigue, it's not well understood. It's understood that there will be fatigue, and they do start to develop heat treatment processes to try and strengthen the metal and try and make it lighter so that they can use it. And so I think that's where the stressed skin comes in to protect the metal from the elements, because it's understood that there will be some degree of fatigue. I don't know of any instances of any problems that come about of it, but as I said, I'm still in the middle of the research, so that might be something again that comes out of what I look at in the years to come.
Yeah, the sort of stress concentration points which come from corrosion are a really fascinating area.
Absolutely. And as you say, that was a problem through the 1950s and 1960s, that there were still issues that came out from that. There were ways to try and overcome that problem, certainly.
Okay, the question here is from John Usher, who asks, with the demise of so many manufacturers after World War One, why not simply reinstate the design or the manufacturing role the RAF had previously held and had given up during the war due to the protests of the private sector?
As ever with these things, it's not quite as simple as that with the sort of the change in production in the First World War. So what we have in the First World War is that the Royal Flying Corps mainly get their aircraft from the Royal Aircraft Factory, which becomes the Royal Aircraft Establishment at Farnborough. So they rely on more public sector production. Sort of in 1912 to 1914, 1915, the Royal Naval Air Service go through the entire different approach and move to the private sector. But as the war increases and the demand on the Royal Aircraft Factory increases and they're unable to meet demand, the Royal Flying Corps start to subcontract in and directly contract these private contractors. And so you have a real competition then. And that's one of the reasons for the formation of the RAF as an independent force, is to try and streamline the procurement process, because it's utterly chaotic in 1916, 1917. In terms of the demands that are being placed on it, the differences for Royal Naval Air Service and Royal Flying Corps aircraft. So they try and streamline that. And then the decision in 1918 is consciously made that this will be a private entity. This is not going to be something that the government does. There are various factors behind that, in terms of the fact that, you know, there's no real need for aircraft in 1918, 1920, because you've got plenty of spares that were already being built up until November 1918. And the government doesn't want to take on the risk of this new technology. We can see it in terms of the attitude of the government with David Lloyd George, when he gives Winston Churchill the choice of either the Admiralty or the War Office, and says, whichever one you go to, you're taking air with you, and I want you to wind it up within 6 to 12 months. So there's an attitude there that the government don't want to be taking the risk of taking on the aircraft, so they leave it to the private firms. And that's something that we can see. You know, the Army, the Navy, they don't want to be involved in building and buying aircraft themselves. The aircraft establishment and the Royal Aircraft Factory is there as a design and development as well as construction site. So it's there to push the boundaries of what's possible. But it's decided, I think, under Septon Branca in 1912, that this is not going to be a publicly owned industry, unlike, say, the arsenals that the Army have and things like that.
Okay, great. It's just that. So we've got somebody who's asking about the Naval Air Service and the extent to which the Air Ministry wasn't just looking at the RAF. How did it incorporate those needs into its all metal policy?
To a large extent, it doesn't. The RAF is responsible for all aircraft, whether it be what becomes the Fleet Air Arm or sort of RAF aircraft, up until 1936. And as far as I'm aware, and I don't know anything that says differently at the moment, the RAF is still responsible for the design, development and production of Fleet Air Arm aircraft, as they're the ones that know how it's going to operate, how it's going to work, how it's going to function in all of this. So I think it's largely, and there is a degree of collaboration with the Navy over what they want for sort of Fleet Air Arm aircraft. But because the decision isn't made until 1936, that move from wood to metal has largely already been made by the industry as a whole. So it doesn't really play a huge amount of importance there.
This question from Steve Dixon. He asks why the Hawker Fury was such a massive step. It wasn't as a monocoque design the way the Spitfire was. I think you touched on it in the way you said that the all wooden parts which were previously being used were replicated in metal. Is that why it was important?
Yeah, it was. Hawker are really at the forefront of pushing this development alongside Supermarine. So like I said, the Supermarine S5, that's essentially the basis of what then turns into various models for the Schneider Trophy in terms of Supermarine, and then goes on to become the Spitfire. It's another sort of leap in technological development with the Fury that sort of sees what can be done. Is it possible, and will it work? And these are sort of questions that are being asked by the RAF and by the industry. Where's the envelope here? Where's the limit we can push this to? If you look at sort of the development of aircraft in the First World War, what we see in 1914 is almost completely different to 1918. This is, again, leapfrogging. What can we do? What advantages can we do? And then we see similar in terms of the Hawker Hart, which is a all-metal biplane. And we sort of put out to subcontracting as well, which causes huge rancor with the industry. They don't like this. Hawker don't like having orders taken off them and given to other firms because they want the money coming in. They've put the time and effort into developing it. They feel, and all the firms believe this, that they should reap that reward of the financial benefit that they gain. So it's, again, sort of, what can we do? Is it going to work? What are the problems we're experiencing, and how do we resolve them? So it's that continually dynamic process that we can see.
Okay, and we would appear to be in august company here, Matthew, because we've got a question from David Edgerton, who's asked that you implied that there were still wooden, perhaps just partly wooden aircraft in the mid-1930s, and then later said essentially that all aircraft were all metal, or nearly so, from the 1930s onwards. What were the wooden aircraft of the late 1920s and early 30s, and in what number were they produced?
Thank you, David. It's a question I don't know the answer to because I haven't gone into that depth in terms of what was actually being produced. This sort of research and everything I'm doing is looking at the policies that the Air Ministry have with the aircraft industry and how they operate and the relationship between the two. So I haven't delved into that depth just yet, but it is something I will be getting to, and always happy to discuss with Professor Edgerton on topics like this. So apologies, I can't answer that question just at the moment.
Okay, we've jumped up for my questions, unfortunately. This question's, I think, touched on a couple of points already raised, which is that the term all metals rather is rather unclear. And there's a difference between metal structures with a variety of coverings, and monocoque and semi-monocoque, and even some late World War II aircraft had fabric coverings in places. What did the Air Ministry really intend when it was moving this change? Is that what it wanted, or its expectations rather, or did it hope to be further ahead by the time 1940 arrived?
I think it would have been wanted to have been further ahead, but it was, the context is restricting what it can do. In terms of the 1920s, the money is restricted, so they can't give the orders that are needed for firms to really be confident that they can expand their production, that they can sort of see a return on investment. And then the 1930s, it's all hands to the pump. We need to get aircraft out. These are the models we've got, I think. So it's difficult. I think the criticisms that have been made of the Air Ministry are a lot of times unfair and rather sort of simplistic in nature, that they're conservative, that they're backwards, that they don't understand this new technology. I think that they do, but I think there's a massive difference between being able to understand something, wanting to do it, and then convincing the industry and actually being able to do it as well. So I think every Air Force would want to be further than they were come 1939, 1940, certainly. But there are certain structural, contextual factors that are making things difficult for them to apply this. In a perfect world, you would have been rolling off the Lancaster, the Spitfire, the Hurricane in massive numbers in 1938, 1939. But the problem the Air Ministry have in that is, do they stop the production of things like the Fairey Battle, which those of you know was a particularly awful aircraft come 1940. But that's giving the firms the experience they need. That's allowing them to keep staff on that have been trained, and they're learning all the time through this process. So it's, again, the Air Ministry are faced with almost impossible decisions in this period, I think, and it makes life a lot more difficult for them to sort of push on the technological boundaries that they would like to do.
Absolutely, it's easy to forget there's no perfect answer in this place. I think it's a question which has been raised in a slightly different way, but I think it's worth expanding on. Is one of the problems the Air Ministry faces in terms of dealing with the aircraft companies that there isn't a great body of mass manufacturing happening elsewhere in Britain in terms of these sort of industries?
I think so. I think it's sort of indicative of the period as a whole that we see a reduction in sort of defence spending. The defence budgets go down. We see the naval treaties that are agreed between the US, the UK, and Japan reducing numbers as well. So I think this is an overall issue that we see an increase in public expenditure on social projects. There's less drive and desire from the people, from public opinion, as politicians view it, for defence projects. They're seen as the sort of the bringers of war, because the only way of being able to maintain profits and maintain their businesses is for war. They need that continual fighting to be able to make what are perceived to be at least massive profits. So I think it's a sort of a general trend that we see throughout the 20th century for a reduction in defence spending, which brings me nicely on to yesterday and today's announcements in terms of sort of an increase in defence spending that we've not seen for a long, long time.
Yeah, I think one of the reasons the Air Ministry often sort of gets beaten up over this point is the success de Havilland have outside of its orderings and the way that it then produces the Mosquito, which of course isn't an all-metal aircraft.
Yeah.
How does that factor into what the Air Ministry was attempting to do? Could a largely wooden fighter have been made with similar techniques?
Possibly, and there are some very good articles out there written by an American historian that says that it was largely because everybody had a faith in metal in America that they pushed for metal, and that wood could have been just as successful. With these counterfactuals, it's always fun. We just don't know. It's entirely possible that it could have achieved the same, but whether or not it would have been able to stand up to the G-forces of dogfighting in 1940. And it's also that relative competition as well. If you're in a wooden fighter against a all-metal monoplane, are you going to be able to compete? And that's a risk that the Air Ministry don't want to take. And it's almost self-fulfilling that everyone believes that metal is this scientific, technologically advanced material that you have to use, therefore you have to use it. It's cyclical, and sort of it imposes itself upon what happens.
Yeah, I was going to say the subcontracting which is possible with the Mosquito, and when you compare it to the production of all metal aircraft, there's a real difficulty in the production process, isn't there? Learning those skills.
Yeah, and subcontracting with the Mosquito is easier to do because you're in a wartime scenario, so you can compel contractors to do it. And this is what happens in the First World War as well, is that you can take a Royal Aircraft Factory design, say the BE-2C, and give it to Blackburn, give it to Shorts, give it to other firms, and you can tell them you're making this because under the wartime controls. When it comes to the interwar period, you haven't got that same compellence available to you. And then when it comes to de Havilland, obviously they decide not to become involved in the ring of firms when that's set up by the Air Ministry, and they can find other customers outside of the ring of firms that's set up. But most of the firms can't, so they're almost driving themselves towards this. And as I said, it's more difficult for the Air Ministry to drive this change, same as Neville Chamberlain finds in rearmament in the late 30s, because it's in peacetime. You can't just tell people you have to work for the aircraft factories. You can't compel them what to produce. You can't subcontract work that they've spent maybe 18 months, 2 years designing and developing to win that contract, and then say 50% of your orders are going somewhere else. And so that one of the things that's emerged from the research I've done so far is that dynamic between the Air Ministry and the aircraft firms, and sort of how they try and exploit that relationship to their own advantage. And I think that continues to this day.
Okay, so this is perfect, Matthew, because we've got time for one more question, and it follows on from that really well, which is asked by Kevin McManahan, I think, probably butchered that name. He says there's a contradiction, seemingly, in your statement that firms were in competition with each other, and the fact that there was also only one customer, the Air Ministry. And so how did the Air Ministry keep firms in business by awarding them all contracts of one kind or another, without, and the byproduct of that was that the management was then deeply conservative to the detriment of the industry? And do you agree with that statement?
No, not really, because there is a competition here, because firms are asked to produce this. So different firms specialize in different aircraft for a start. So Supermarine very much focus on fighters. Ferries do things like light bombers, seaplanes, same as shorts. So different firms have different specialities within the aircraft industry. But what happens in the mid-1920s is that a ring of firms are established which will be allowed to bid for contracts. So that the aircraft industry is almost artificially supported and created by creating this ring of people. And so this competition, different firms are doing different things. That's how we have the Hawker Hurricane and Supermarine Spitfire emerge in 1940 after their development in the mid-30s. Because there is this competition between them. They are in competition despite there only being one customer. They get, if you want a fighter, you'll go to 3 or 4 firms with your specification, and whoever designs the best 1 or 2 aircraft out of those 3 or 4 firms that are making them will then be awarded that contract. So there is a degree of competition that exists, the same as if you want to buy an aircraft today, you might go to BAE, you might go to Boeing, you might go to Lockheed. There's still the one customer in terms of the UK government, but there are several different firms that are able to bid for that work and to show what they're capable of, technologically speaking.
I could go on with you, Matthew, talking about this for ages. It's a fascinating subject and one I really enjoy looking at. But unfortunately, we've run out of time. I want to thank you for your time so far. You've been very generous with it. I should say you do have a book currently out, which is based on your PhD, The Development of British Tactical Air Power, 1940 to 43, available at all good bookshops. But you're also on social media. Can you tell us your social media handle?
I am. I'm on Twitter at tac_air_power, and sort of heavily linked to the book and the PhD thesis.
You've stolen a really good Twitter handle there, I think. It's unfair on the rest of us. But thank you very much for your time. I do hope that some of you will join us as well for our next lecture on the 11th of December, when Tom Hopkins will present on Coastal Command. But all that's left is to thank you again, Matthew, for your time. Thank you.
Oh, thank you very much. It's my pleasure.